geometry, and welcome to the second video or the second lesson in Unit 2 on reflections on the coordinate plane. All right, so as promised, right, so I'm going to shorthand this Unit 2 title, and again, you have to keep writing this down. So we are talking about congruence transformations. So congruence transformations and triangles. And we are going to focus today on, this is number 2, reflections on the coordinate plane. Reflections on the coordinate plane. The coordinate plane. I got to work on my centering skills, but you know what I mean. In the last videos, we talked about the different congruence transformations, the different rigid motions, reflections, translations, rotations. So now let's focus on how can we perform them on the coordinate plane. Now, on the coordinate plane, you're going to see 3 common reflections that we do, okay? So the first reflection is across the x-axis. So we're going to do a reflection across the x-axis. X-axis. Okay, so what we're going to do is we're going to draw a little picture. All right, so here is my coordinate plane. Okay, and on that coordinate plane, I'm going to put a point. Let's call it point A right here in the first quadrant. So there's point A, and let's give A the coordinates of x and y. Okay, so for this reflection, your pre-image is going to be x, y. Okay, so now I want to know, once we do this reflection across the x-axis, what is our image going to be? Now, we're going to call our image A prime, right? Remember that apostrophe? But now, what's going to happen to our x and our y? So let's talk about this, right? So our x-axis is the line of reflection. So I'm going to highlight the x-axis like this. So this is our x-axis. That's our line of reflection. Well, if I take another color, to get to that x-axis in a perpendicular fashion, remember, perpendicular bisector, we need to go straight down. Okay? When you go straight down, that's how you create the right angle. Well, A prime is going to be the same distance on the other side of the x-axis. So if we go down the same exact distance, that is where A prime is going to be. Now, let's see, and again, same distance, so congruent. So if you notice, to get to this point A prime, we would still go to the right the same amount. So your x is going to remain the same. But now, instead of going to the right and up y, now we're going to the right and down y. So your y value is going to become, and I'm going to say this, opposite. The opposite of y. So this negative does not mean negative y. Doesn't mean negative y, it means the opposite of what y was. Opposite. So this is what happens when you reflect across the x-axis. Your point A at xy becomes A prime at x opposite of y. So you're going to see there's some rules, so this is one of the rules. Okay, next, what happens when we do our reflection across the y-axis? Across the y-axis. Okay, so let's draw a picture of a coordinate plane right here. And again, let's go ahead and put A in that first quadrant. And again, give it coordinates of x and y. So again, I'm looking to see my pre-image x and y, right, the coordinates. What happens when I do this reflection? Okay, so let's trace the y-axis. So the y-axis is now my line of reflection. So now, to get from A to that line, now I have to go horizontally to the left. Okay, so there's my perpendicular distance from A to the y-axis. So now to get to A prime, I have to go to the left that distance more. All right, about good. And there's my point right there. So this will be the image A prime. So if I take a look at how do I get to that point, well now, instead of going to the right x, I now have to go to the left x. So now your x becomes opposite, but your y, notice we're at the same y level, your y stays the same. And this is the image after a reflection across the y-axis. So again, these two distances are the same. That's why the x is the same number, but it's just opposite in nature. Okay? So over here, your pre-image xy becomes your image opposite of xy. Okay, and then the last major reflection that you need to remember, or try to remember, is going to be a reflection across y equals x. So we're doing a reflection across y equals x. So again, I'll draw my coordinate plane. I'll put my point A in the first quadrant. Again, it has an x and a y coordinate. And again, I'm trying to see what is happening to my pre-image A, which is located at xy, to get my image A prime. Well, we have to understand what the line y equals x means. So the line y equals x means that it has a y-intercept of 0. So let's break this down here. It has a y, so y equals x, has a y-intercept of 0 and a slope of 1 over 1. So essentially what it looks like is this. It goes to the origin, and it goes up 1, right 1, up 1, right 1, just like this. This is the line y equals x. It goes diagonally, very nicely through the coordinate plane, up and to the right, because we're going up and to the right. It's a positive x. So now, because this line is diagonal, to get to it perpendicularly, you have to go diagonal in the other direction. So if I look at where A is, I would have to go this way to get to it perpendicular. So that's not horizontal, that's not vertical, that's also diagonal. Okay, so be aware of that visually. So now I have to keep going diagonal that same amount, and there's where A prime is going to be. Okay, now to get the coordinates of A prime, all you have to do, and I want you to think about this, right? To get over to A, you have to go to the right so many and up so many. To get to A prime, right, it looks like you only have to go to the right a little bit, but then you have to go up a lot more. So to me, what it looks like is the values of x and y switched. And that is exactly what happens when you reflect across the line y equals x. If to get to A, you had to go x to the right and y up. Now to get to A prime, you go y to the right and x up. And the coordinates switch positions. And this is how you get that reflection. So when you're reflecting across the line y equals x, the pre-image xy at A becomes the image at A prime of y, comma x. Of the rules, this is the one that I would try to remember, just because it's not as, I feel like the other ones being horizontal and vertical are a little bit easier to see. This one might be tougher to see, so again, just try to memorize that across y equals x, x and y switch places. Okay, there will be 2 assignments on Delta Math. Make sure you just choose one. If you're feeling like you want a challenge, try the extension one. If not, just do the number 2 assignment for Unit 2. All right, thanks for watching, and we will see you next time.